Bismillahirrahmanirrahim and Assalamu alaikum dear students. This is the second lecture of magnetism. In last lecture we have started the topic magnetism, and this is the second lecture of this series of this physics portion of magnetism. I am Adnan Khan, physics teacher, Bahria Town International Academy. This lecture is for grade O2. The contents of today's lecture will be the method of magnetization and demagnetization of magnet. In this lecture we will discuss in detail how to magnetize and demagnetize the magnet, and these are very important topic regarding CIEs, MCQs and short question. Topic is very important. Now after this lecture the students will be able to know about the solenoid, because in higher studies in higher physics the term solenoid is very important in the field of electromagnetism and electromagnetic induction. Students will be able to know the stroking method, electrical method of magnetization, and the stroking method of demagnetization and magnetization. Demagnetization method will also be discussed, just like hammering, heating a magnet, and electrical method. For both the electrical method we will discuss the solenoid, concept of solenoid, and we will use the concept of AC current and DC current for magnetization, demagnetization. And the last portion will be, we will discuss the magnetic properties of iron and steel. We will compare these two material. They have specific uses. Iron is soft magnetic material, ferromagnetic material, so it can easily be magnetized and demagnetized, compared to steel. Steel is hard magnetic material. It is a material which is difficult to magnetize, and when it gets magnetized it is difficult to demagnetize steel. So the purpose of iron, we can use, we will study in detail that iron is also used for making electromagnet compared to steel for making permanent magnet. Now let's discuss the methods of magnetization. For example, if we have a steel bar and we want to make it magnetize it, so the method is the stroking method. This method which you are seeing is known as stroking method. First of all, you have to take the north pole of, you have to take a magnet, permanent magnet, take either north pole or south pole. You're not allowed to change the poles of magnet while you're stroking the steel bar. You will place the steel bar and then you will stroke away the steel bar with permanent magnet. But point to be noted, during this method you will use a single pole of magnet, either north or either south, but you will not change the poles of magnet. Now you have to stroke away this steel bar with the help of permanent magnet continuously, and after a certain interval of time you will see this steel bar will behave like a magnet. But in this process it is time taken process, because steel bar when it gets magnetized is difficult to magnetize. It will take some time. This method is known as stroking method. It can be single stroking method, it can be double stroking method. It depends, if you are using two magnets, so then it is known as double stroking method, and if you are using single magnet, it is known as single stroking method of magnetization of steel bar. Now in this method what is happening, in last lecture we also discussed this, inside the steel bar there are tiny magnets. These tiny magnets cancel the magnetic fields of each other. So steel bar, it is not magnet, but if you are stroking, you are providing external energy, expenditure of external energy. You are stroking with the help of permanent magnet. So what is happening inside this steel bar, these tiny magnets are aligned with each other, or now after certain amount of stroking, after certain time of stroking, if you have waste some mechanical energy, so because of this mechanical energy, because of expenditure of this mechanical energy, the tiny magnet inside the steel bar are now aligned with each other. Their forces, their magnetic field are now reinforcing each other, and the output and the total result of this process is there is a net magnetic field, which is the reinforcement of all the magnetic field produced by the tiny magnets inside the steel bar are add up together, they are reinforce each other in the final, and there is a net resultant magnetic field is generated. So this is why the steel bar become magnet. This is the one method. Now the next method is electrical method. Now you're seeing a wire which is wrapped in a cylindrical shape. This wire, if any electrical wire, a conductor which is wrapped in cylindrical shape, it is known as solenoid. This word solenoid is new for the student. So solenoid is a wire, electrical wire, a conductor which is wrapped in cylindrical shape. This is known as solenoid. Now first, in this electrical method is very famous. Few points student must know. Point number one is battery is connected, means the DC supply. DC supply is the DC current is the direct current provided by the cell, battery, DC generator, etc. So they provide DC current. It is unidirectional current. We will place a steel bar or any metallic bar inside this solenoid, and we will connect the switch. When we connect the switch, the current will start flow. The current will pass through this whole circuit. Because of the influence of DC current, the tiny magnets, the small tiny magnets, small moving charges inside the steel bar will now be aligned with each other, and there will be a net magnetic field. So after this process, this application of external DC current to a material, to a steel bar which is placed in solenoid, so the steel bar now will become magnet. This method is known as electrical method. In CI's MCQs, they focus on DC current. So battery is there, which is representation of DC current. Point to be noted, DC current must be there. So this is the electrical method of magnetization. If you have steel bar, we can convert this steel bar into magnet by using this electric. Now, so the first two we discussed was the stroking method of magnetization and electrical method of magnetization. Now we will discuss the demagnetization method. If you want to make a magnet and convert it into a non-magnet, you want to make, externally what will happen inside the magnet, the charges, the tiny magnets which are aligned with each other, now because of external forces, heating, hammering and electrical method, this alignment of tiny magnet will be disturbed, and finally we will get a piece having no alignment of tiny magnets inside. So the magnet will be demagnetized and it will not behave like magnet anymore. Now for example, the first method is hammering. Point to be noted, there are some magnets available in physics lab. In any physics lab, these magnets are generally made up of insulating insulators, and these are soft material which can easily be broken down. While doing experiment of hammering, you have to use a steel magnet which can tolerate the blow of hammers. Generally the magnets available in physics lab, in any other lab, it is soft magnet which cannot tolerate the blow of hammer. So if you're using this method, you have to use the steel magnet which has the tolerance to they have the tolerance to face such a huge force because of hammering. Now There are methods of demagnetization. The first is hammering, and the next is heating, and there will be electrical method. Now, the method of demagnetization, the first is hammering, and just like we discussed, because of hammering, the inside tiny magnets, uh, their vibration increases, and because the vibration increases, their alignment is disturbed, so they become demagnetized. The next method is heating. Heating, because of heating also affect the alignment of charges inside the magnet. If we providing heat energy, the thermal energy to a magnet, if we place into fire and provides a high temperature to magnet, because of this process, magnet also demagnetizes, and it no more behave like magnet. Now the next method is electrical method. Now there is a difference between electrical method of magnetization and demagnetization. Point to be noted: DC current, direct current, the current obtained from battery, cell, DC generator, all these sources provide direct current. For magnetization, if you have a piece of steel bar, you want to convert it into magnet, you have to use the same process, but the source current will be direct current. Now in the same way, if you have a magnet, a piece of magnet, and you want to demagnetize it, you will use AC current, you will use AC battery, and this AC current will be used. And the method is, first of all, you have to place magnet into the solenoid. Solenoid, again I repeat, solenoid is if a current, if a wire, if electrical wire is wrapped in cylindrical shape, now it is known as solenoid. And why we make solenoid? Because we want strong internal magnetic field. If we want a strong magnetic field in a region, so we make solenoid. Inside this wrapped wire cylinder, there is a strong magnetic field inside the solenoid, just like a bar magnet. So solenoid somehow behave like a bar magnet. So now the method is, first of all, you have to switch on the current. Magnet is placed inside the solenoid. You have to slowly withdraw the magnet. The current is there is insulating material, so there is no danger of electric shock. So you have to remove this magnet slowly 2, 3, 4, 5 times. By repeating this experiment, because of the influence of magnetic field, which is changing magnetic field inside the solenoid, because of effect of this changing magnetic field inside the solenoid, the magnet now will be demagnetized. So this is another way. The method is, you will use AC current, you will place magnet inside the solenoid, inside the cylindrical wire, which is in the form of cylinder. You have to place the magnet and you have to withdraw it. Now in the method of magnetization, there is no withdrawal of magnet, but you have to place the magnet inside the solenoid, you have to provide DC current, and that's it. Now in case of demagnetization, if you want to demagnetize the magnet, you have to provide AC current, place the magnet in solenoid, and you have to slowly remove it for multiple times, 3, 4, 5, any number of times, and it will help, and this magnet demagnetize. Now in the previous lecture we also discussed the internal structure of a magnet and a non-magnetic material. For example, if you see this figure, the domains are randomly aligned. The first left case, it is mentioned that domains are randomly aligned. And what is domain? Domain is a piece of magnet, inside region in which all the charges are aligned with each other. So these smaller portion in which charges are aligned with each other, this region is known as domain. So in some domain, charges are moved, the field, magnetic field produced by the charges are, some in cases it is upward, shown with arrows, in some cases it is leftward, rightward, downward, north, south, east, west. It is random. So because of this random and there is no alignment in these charges, there is no net magnetic field produced by the first case, which is on the left. So we say that this is non-magnetic material. We can convert a non-magnetic material into magnetic domain aligned with external field if we place this same material in which domains are not aligned with each other in a magnetic field, and this material is ferromagnetic, is affected by magnetic field. Then these domains, these charges, these tiny magnets inside the magnet will be aligned with each other, and there will be net magnetic field in a certain direction. The direction is shown, so there will be magnetic field. So this is the inside story. If you want to magnetize a non-magnetic material, you will go from left to right. This figure you have to read from left to right. No alignment, and because of electrical method, because of another method which is explained in this magnet, which is stroking method. So DC electrical method convert the figure from left to right, non-alignment of domains to alignment of domain. It is because of external field. External field may be stroking method, or it can be the field due in the solenoid, which is due to DC current. And in case of demagnetization, you have to read it from right to left. The figure shown the magnetic domains in the right, that they are perfectly aligned with each other because of heating, hammering, and AC electric method. This alignment is disturbed. You can read from right to left here shown. Then the left side of this figure, the internal structure is known. Domains are not aligned with each other, they are randomly aligned. So we say that is the method of magnetization and demagnetization. Now this is the important part of your syllabus, that we discuss the properties and compare the properties of iron and steel. Iron is a soft magnetic material and steel is hard magnetic material. The word soft and hard means soft magnetic material is easily to magnetize and demagnetize. We can easily magnetize iron. It will behave magnet when we supply current, and if we remove the current, we remove the connection, these will be this iron will not remain magnet anymore. Now hard magnetic material are difficult to magnetize, and when they get magnetized, it is very difficult to demagnetize. So easy to magnetize and demagnetize, and harder to magnetize and demagnetize. Because they are harder to magnetize and demagnetize, they are known as hard magnetic material. Iron is used to make electromagnet, transformer core, and magnetic field, and steel is used and is good in making permanent magnet because it has the ability to retain its magnetic field for longer time. And bar magnet are used also they can use also making steel. This was the second lecture of demagnetization and demagnetization magnetism portion. This is assignment number 2 for the students. You have to answer the following question. The first question is how a magnet is demagnetized electrically. What is the electrical method of demagnetization and magnetization? Demagnetization as well as magnetization. Why hammering and heating demagnetizes the magnet? Now in first two questions you have to write electrical method of magnetization as well as demagnetization. Just you have to mention following points. In demagnetization you have to use AC current and then removal of magnet from solenoid multiple times slowly. So by repeating this process, the magnet will not be magnet anymore. Now in demagnetization was this AC method, and magnetization you have to also write the method of magnetization. And magnetization is you have to use DC current, and you have to place a steel bar or any object, magnetic material. You want to make it magnet, you want to convert it into magnet, you have to place in solenoid and you have to provide a DC current. Now question number 3. In the question number 3 you have to give the internal reference of internal structure of magnet. Just like in the last previous slide we discussed why heating hammering and heating demagnetizes the magnet. Why hammering and heating method, why the provision of mechanical energy and store thermal energy, because of thermal energy, why a magnet demagnetizes. So you have to answer this question with a reference to an internal structure, the internal domain, the tiny charges present inside the magnet which also behave like a magnet. You have to give the alignment of domain. You have to give these references while answering this question, why hammering and heating demagnetize. So that's all for today. If you have any question up to this point, you're most welcome to ask question. Feel free to ask question, and teachers are always there to answer your queries and question. Jazakallah, and thank you. Allah.